Hello, everybody. This is Gigi from Kauai Community College. This video is about finite differences. So let's get started. So before we start on finite differences, I want to review with you a little bit about calculus, right? You have just finished Calc 1, and I'm sure you totally will be able to do this in your head, right? Suppose you have a cubic function, x to the third power minus 3x squared plus 5x minus 7. And I asked you for the derivative. So you should be able to say it is 3x squared minus 6x plus 5. Yeah? Okay, now keep going. Take the derivative of that. And the second derivative is 6x minus 6. All right. Well, what do you think happened when you take the derivative again? Meaning, what's the third derivative? And that's how we denote the third derivative, not f to the third power, but the third derivative of x is just a constant 6, right? So if we were to think about what's going on here in terms of a pattern of a polynomial function and its derivative, well, you started out with a cubic function. So the derivative of it is a quadratic. And a derivative basically is the slope of the tangent line, right? The slope function there. So the slope function of a cubic function is a quadratic. And then a slope function of a quadratic is a linear function. And then, of course, we know what makes a line, a constant rate of change, so that the slope of that is a constant, right? Now, we are going to apply this understanding into the concept of finite differences. Okay, finite differences. And what does that mean? Well, finite differences is a way to find a pattern that is given to you, and you're looking for that explicit function. So previously, I actually gave you the function, right? And then you take the derivative. But here, I just give you a table of values, and we are looking for the function. Okay, so we're going to go and use the concept of your slope function and deduce the fact that this is going to be, say, a quadratic, a cubic, or something to the fourth power or whatnot, right? So, so again, and that's the concept of finite differences. And so let's see how this works. Okay. If this is your function value, that's the y, right? Then what we can do is go ahead and take the slope, meaning let's calculate the slope. For the first set of numbers, the change in y is 2, and the change in x is 1. So the slope is 2. From 3 to 6, the change in y is 3, and the change in x is 1. So that's 3, right? Now, keep going. The slope is 4 there, and then the slope here is 5, and then you just kind of ignore what the change in x is because it's listed in order, so the change in x is always 1, right? So basically what we're doing is we are just taking the difference. Therefore, this is what we call finite differences, okay? And that would be 6. All right, now let's keep going with the process and find a slope function. And in this case, the function is a list of numbers, right? Rather than an explicit equation, and because that's what we're looking for. All right, so here, take the slope again, you have 1. All right, so let's go backward. If that's constant right there, then the next level up should be linear. And then the thing that we are looking for is a quadratic. Therefore, the function f of n is going to be a n squared plus bn plus c. That's the quadratic function, right? Now, how do we find that quadratic function? Our job is to go and find out what a, b, and c are. And how we're going to do that? Well, we're going to use these points. When x is 1, y is 1. When x is 2, y is 3. When x is 3, y is 6, but really we don't have x and y, we have n and f of n. It's the same thing, right? So let's plug in when n equal to 1, then you will have n 1 squared is 1, right? So 1a plus 1b plus c equals 1. And when n is 2, you have 4a plus 2b plus c equals 3. And then when n is 3, you have 4a plus 3b plus c equals 6. Now, how many of these do you have to plug in? Well, it depends on how many unknowns you have. If you here we have 3 unknowns, so we need a system of 3 equations. Okay, now if you have 4 unknowns, then you might want to plug in 4 points so that you can get 4 equations system so that you can solve for the variables. Okay, now how we're going to solve for this system? We're going to use elimination. Okay, you see that C hanging out there? That's very tempting. So what I'm going to do is I'm going to take equation number 2 here and minus equation number 1 here. I will have 3a plus b equals 2. And then I'm going to go ahead and take that number 3 right there minus number 2. And I have 5a plus b equal to 3. Perfect. You see that b right there? I can just go ahead and eliminate b by taking the bottom equation minus the top equation. And I will have 2a equals 1. Therefore, a must be 1/2. Nice, right? Well, now that we know a, that's a third of the way through because we need to solve for b and c also, right? How we're going to do that? We're going to just go ahead and plug a back in. So 3 times 1/2 plus b equals 2. Therefore, b must be 1/2. Okay, now let's go back to here, this first equation here. Plug in a and b to solve for c. Well, 1/2 plus 1/2 plus c equals 1. So c is going to have to be 0. So the equation that we are looking for is f of n is equal to 1/2 n squared plus 1/2 n. Now, if we write it as a common denominator and factor out the n, we would say the function that we are looking for, or the nth term of this function, is n times n plus 1 all over 2. Okay, and that is how finite differences work. It's based on the concept that we've learned in calculus, meaning the slope function. All right, now let's look at another example. Okay, so go ahead and take the differences. So the first difference is 3, 6, 20 minus 10 is 10, 35 minus 20 is 15, 56 minus 35 is 21. All right, so we're not there yet. It's not a constant yet. Let's go down to constant. Now, this can be done, finite differences can be done when your function is a polynomial, right? Otherwise, it wouldn't work. So let's take the differences again here. So that's 3, 4, 5, and I see the n. If you take the differences again, that's 1, 1, and 1, right? So here, this is a constant. That means this level is linear. And this level must be quadratic. So what we are looking for is a cubic function. Okay, so what we're looking for is a cubic function. What does that mean? F of n is going to equal to an to the third plus bn squared plus cn plus d. Okay, so this is that tedious process where you have 1 unknown, 2, 3, and 4 unknowns. So you have to plug in 4 different points, 1, 2, 3, 4. I'm going to plug in those 4 different points to get a system of 4 equations and 4 unknowns so that I can go ahead and use elimination to solve. okay? And the system that I will get is this. Now you go ahead and pause this video, solve this system to see if you'll get the answer that I will get, okay? So don't cheat now, go ahead and do that before you move on. So pause the video, solve this system, because the next thing I'm gonna do is show you the answer. Okay, so the answer to this system is A equals 1/6, C is 1/3, B is 1/2, and D is 0. So the function that we are looking for is 1/6 n to the third plus 1/2 n squared plus 1/3 n. Now, if we clean that up and get a common denominator of 6 and then factor it out, f of n is this nice looking function. N times n plus 1 times n plus 2 all over 6. And that is how finite differences work. It's kind of fun. I love this concept when I was going to school. So hope you enjoyed this. The next video that we're going to do is the principle of mathematical induction. And then we're going to see how finite differences work alongside with PMI. Okay. And we're doing proofs. So it's really cool. It's fun. And that is it for this video.